In this step, let's focus on container orchestration. In the last step, we talked about Docker and containers. We saw that Docker brings in standardization. Now, what is the need for container orchestration? Let's imagine that you have Docker images built for each of these microservices. So you have Docker image for movie service, customer service, review service, booking service, and fare calculation service. Now you'd want to deploy them to a production environment. You'd want to be able to run these microservices in your production environment. The thing is, when you go for a microservice architecture, there are a number of complex needs. Let's look at one of these requirements. I'd want to be able to run 10 instances of microservice A container, 15 instances of microservice B container, and so on and so forth. Let's look at some of the important features that are typically needed in microservices architectures. Number one is auto scaling. The load on each of these microservices can be different. A review service might have a lot of load, whereas the booking service might have less amount of load. So you'd want to increase the number of containers for a specific microservice or decrease the number of microservices based on the number of requests or based on the number of users. So you'd want to be able to scale up and scale down the containers based on the demand. You'd also want service discovery. You'd want to help microservices find one another. A review service might want to talk to movie service, or it might want to talk to customer service. You don't want to hardcode the URL of the movie service and the customer service in review service. You'd want the review service to be able to dynamically find out the customer service. This is what is called service discovery. We already talked about the fact that we would have multiple instances of each of these microservices, and therefore load balancing becomes important. You'd want to be able to distribute load among the multiple instances of a specific microservice. You also want self-healing. Whenever we go to the cloud, we assume failure. Some of the instances of your microservices will fail. So you don't want to be able to detect failure. You don't want to be able to identify that a specific container is not healthy. And you'd want to be able to replace it with a healthy instance. So you'd want self-healing. You want to do health checks and replace failing containers with healthy containers. And you also want zero downtime deployments. Before the emergence of microservices architecture, you had one monolith. Maybe you are deploying it once a week, or maybe once a month, or once every few months. But when you're going for microservices architecture, you are doing constant deployments, maybe a few times a day. And therefore, having zero downtime when you're doing deployments becomes really, really important. You'd want to be able to release new versions of customer service, review service, movie service without having any downtime. So what we are talking about is the fact that having individual containers is not sufficient. We would want to be able to run multiple instances of these containers and orchestrate them. And that's where container orchestration comes into picture. With a typical container orchestrator, you can create a cluster. You can say, I would want a cluster of EC2 instances, or I would want a cluster of virtual machines. And you can use the container orchestrator tool to deploy your microservices to the cluster. So you can provide the container image and the configuration to the container orchestrator, and the container orchestrator would deploy the microservice to the cluster. In addition, typical container orchestrator tools provide all the features that we are talking about in here: auto scaling, service discovery, load balancing, self-healing, zero downtime deployments. These are some of the basic features that are provided by most container orchestrators. Now, what are the container orchestrator solutions in AWS? Let's look at them right now. Kubernetes is one of the most popular container orchestrator tools today. And the service in AWS, if you want to make use of Kubernetes, is Amazon EKS, Elastic Service for Kubernetes. I'm calling this a cloud neutral option because Kubernetes can be run in AWS, Azure, Google Cloud. So there are managed services for Kubernetes in almost all the cloud platforms. And one important thing for you to remember is that EKS does not have a free tier. So if you create an EKS cluster, even if you are in a free tier, you would need to pay for it. AWS also has a AWS specific container orchestrator solution. It's called Amazon ECS or Amazon Elastic Container Service. Even with ECS, you can create a cluster and you can deploy your microservices to the cluster. In addition to EKS and ECS, you have Fargate. Fargate is serverless ECS and EKS. When you're using ECS or EKS, you'd need to manage the cluster. You need to decide how many EC2 instances should be in the cluster. You need to decide what operating system, what hardware should be used for the EC2 instances in the cluster. However, when you're using Fargate, you don't need to worry about all that. You just need to specify your microservice configuration, and Fargate would take care of the cluster. So I would call Fargate as serverless ECS and EKS. So if you want to use ECS and EKS in a serverless way, you can go for Fargate. Similar to EKS, it's very, very important to remember that AWS Fargate also does not offer a free tier. In this step, we talked about the need for container orchestration, and we talked about the different container orchestration solutions in AWS. We talked about the cloud neutral option based on Kubernetes, which is Amazon EKS or Amazon Elastic Kubernetes Service. We talked about the AWS specific option, which is Amazon ECS or Amazon Elastic Container Service. And we also talked about how we can use EKS and ECS in a serverless way. That's where we can go for Fargate. I'm sure you're having a wonderful time, and I'll see you in the next step.